Greetings, chemistry students. This is the video key for mole mass and mass mole conversions using dimensional analysis. So my first problem, before we get started, here's what you're going to need: a calculator and also your chem helper. So if you need to, go ahead and pause this video so that you can gather your materials. Okay, so let's get started. Number one is asking us how much does 10 moles of silicon weigh in grams? Well, whenever you have a problem where it's asking you a mass in grams, one thing that you have to remember is you need to find the molar mass of the compound or the element that the problem is looking for. In this case, we want to know how much a certain amount of silicon weighs in grams. So look on your chem helper and find the atomic weight for silicon at the bottom of the box. For silicon on the periodic table, silicon is atomic number 14. And you'll see that it is 28.09. What this means is that silicon is going to weigh 28.09 grams in 1 mole. Also, you can say that as 28.09 grams per mole. So now we're going to set up our dimensional analysis table. In order to do that, you draw a horizontal line, and the first thing that you write on the left-hand side is what you're given in the problem. In this case, we're given 10 moles of silicon. So write that there and then draw your vertical line. And the next thing that we do is we demote the unit. What that means is we're going to write moles of silicon here at the bottom. And we already know that 1 mole of silicon is equal to 28.09 grams. Now remember that we're looking for grams in the problem, and since I have my unit grams at the top of my dimensional analysis table, that means that I'm done entering numbers and setting things up. So now I can do the fun part, which is crossing out the units that are on the top and on the bottom. So I can cross out moles of silicon on the top and on the bottom. I'm left with 10 and 28.09 on top. So what this means is I'm going to multiply 10 times 28.09, and then I would divide that by the number that is left on the bottom, which in this case is the number 1. And since it's 1 on the bottom, all I have to do is multiply 10 times 28.09, and when I do, I get 280.9 grams of silicon. And this is your final answer. So in every answer, you need to have the number, you need to have your unit, and you need to have the compound that we're looking for in the problem in order to get full credit. So this would be a 3-point problem. All right, next, how much does 3.4 moles of water weigh in grams? Well, you know that water is H2O, and since we're looking for mass, the first thing we have to do is find the molar mass of water. In order to do that, we need 2 hydrogens, and we need to add it to 1 oxygen. So 2 times the molar mass for hydrogen, which is 1.01, plus the molar mass for oxygen, which is 16, gives me 18.02 grams per mole. Draw your dimensional analysis table. Write what you're given in the top, 3.4 moles of water. Draw your vertical line. Demote moles of water to the bottom. We already know that 1 mole of water is equal to 18.02 grams of water. Cross out the units that are on the top and the bottom, and we're going to multiply the numbers across the top. So we get 3.4 times 18.02 divided by 1, and this is equal to 61.27 grams, because that's what I'm left with at the top, of water. And I'm going to go ahead and circle my answer. Number 3, how much does 5.3 moles of carbon dioxide weigh in grams? First, find the molar mass of carbon dioxide. CO2 is equal to C plus 2 oxygen, which is equal to 12.01 plus 2 times 16, which is equal to 44.01 grams per mole. Draw your dimensional analysis table. Write what you're given first. 5.3 moles of, let me just make my section a little bit larger here, of CO2. I'm going to put 1 mole of CO2 at the bottom, and on top I put the molar mass, which is 44.01 grams. Cross out moles of CO2 because it's on the top and the bottom of our dimensional analysis table, and now we're going to multiply our numbers across the top. 5.3 times 44.01 divided by 1. And my final answer here is 233.25 grams of, CO2. And then you need to be sure to circle your answer. The next problem, how much does 0.04 moles of lithium chloride weigh in grams? First, find the molar mass of lithium chloride. This is equal to lithium plus chlorine, which is 6.94 plus 35.45. And again, I'm getting those numbers from the Chem Helper on the periodic table, and that equals 42.39 grams in 1 mole. Draw your dimensional analysis table. Write what you're given in the problem first. 0.04 moles of LiCl. Demote the units. We're going to put moles on the bottom. And then on top, we write down how much 1 mole of lithium chloride weighs. 42.39 grams. Cross out the units that are both on top and bottom of your dimensional analysis table, and what we're left with is 0.04 times 42.39 divided by 1, and that answer is 1.70 grams of LiCl. So try to get 2 numbers after your decimal point. So make sure that you're rounding to the hundredths, please. Okay, the next one. How much does 15.7 moles of potassium iodide, that's Ki, weigh in grams? Well, find the molar mass of Ki, and that is, K plus I, just one of each. So that's 39.10 plus 126.90, and when I add that together, I get 166 grams in 1 mole of potassium chloride. Draw the dimensional analysis line. Write what you're given at the top. 15.7 moles of Ki. Draw your vertical line. Demote your units. You're going to bring moles of Ki at the bottom. We know that 1 mole of potassium iodide is equal to 166 grams. Cross out your units, multiply the numbers across the top. So we get 15.7 times 166, and then you divide by the number that's at the bottom, so we're dividing by 1, which doesn't, again, really matter that much. But when you do this math, you get 2,606.2 grams of Ki, and then of course circle your answer. Okay, our last one. what is the mass in grams of 2.4 moles of aluminum hydroxide? So this one is worded a little bit differently, but we're still looking for grams. So the first thing that we have to do is figure out what the molar mass of aluminum hydroxide is. So aluminum hydroxide is 1 aluminum plus 3 oxygens plus 3 hydrogens. And so when we plug in these numbers, we get 26.98 plus 3 times 16 plus 3 times 1.01. And when we add all of that together, we get 1,298.07 grams per mole. So now we draw our dimensional analysis table. We always start with what we're given, which is 2.4 moles of AlOH3. We know that 1 mole is equal to 1,298.07 grams. Whoops, let me put my units here. And cross out what's on the top and on the bottom. Again, we're left with grams, and so we need to multiply 2.4 times 1,298.07. We're going to divide that product by 1, and when all is said and done, we get 3,115.37 grams of aluminum hydroxide. And then, of course, circle your answer. Okay, so that's how we convert from moles to grams, because we're given moles and we're trying to find grams. On the next page, we're going in the opposite direction. Now we are given grams and we have to find moles. But once again, since we have grams in our problem, we need to find the molar mass of the compounds in question in the problem. So how many moles equals 59.3 grams of water? So here we have water, which is H2O, and that's equal to 2 H's plus 1 O, which is 2 times 1.01 plus 16, which is 18.02 grams in 1 mole of water. So now we're going to draw our dimensional analysis line. We always write down what we're given first. In these problems, we're given grams. So we're going to write 59.3 grams of water. And now in this problem, we're demoting the unit grams to the bottom. So we have grams of H2O. And we're looking for moles. So we're going to put moles of H2O at the top. So what numbers go here? Well, the numbers that we found when we found the molar mass. We know that 18.02 grams is equal to 1 mole. So we're going to put the number 18.02 next to grams because it's next to grams here. And we're going to put the number 1 next to moles because we don't have a number next to moles, therefore we always assume that it's a 1. Cross out the units that we have in the problem. And now we're going to multiply the numbers across the top. So now we have 59.3 times 1, and we divide by the number that's at the bottom, divided by 18.02. So when you plug this into your calculator, you would multiply 59.3 times 1, and then we would divide it by 18.02. And when we perform that math calculation, we would get 3.29 moles of water. And again, circle your answer, and remember that your answer for full credit needs to have the number, the unit, the compound. All right, next, how many moles are in 305 grams of chlorine, which has the formula Cl2? Well, Cl2 is equal to 2 Cl atoms, which is equal to 2 times 35.45, which is equal to 70.9 grams in 1 mole. Draw your dimensional analysis table. Write down what you're given. In this case, it's 305 grams of Cl2. Denote the unit, grams of Cl2 on the bottom, and then we were looking for moles, so we're going to put that at the top. What number goes next to grams? What's the number that's next to grams in our molar mass calculation? So this is 70.9, and we put the number 1 next to mole because here by mole we have no number there, so we always assume that there's a 1. So now what we do is we multiply the numbers across the top. So we have 305 times 1 divided by 70.9, and when you punch that into your calculator, you would multiply 305 times 1, which is just 305, and then hit your division sign, divided by 70.9, and when you do that math, you get 4.3 moles of Cl2. Oh, and I forgot to cross out my units here. And like we're left with moles of Cl2, and so that's why we have that at the end of the problem. Okay, next one. How many moles are in 1,000 grams of calcium? So calcium is standing alone, so calcium simply has the molar mass of 40.08 grams per mole. So we're going to draw our table here. We always start with what we're given, so we have 1,000 grams of calcium. Denote the unit and write what we're looking for at the top. Well, we have the number 40.08 next to grams in our molar mass calculation, so we'll simply write 40.08 here, and that is equal to 1 mole. Multiply across the top. So we have 1,000 times 1. We're going to divide that by the number at the bottom, which is 40.08. When you plug this into your calculator, it would simply be 1,000 divided by 40.08. Remember, I'm not putting the 1 there anymore because you know 1,000 times 1 is 1,000, so I don't have to keep saying that, I don't think. So when you divide this, you get 24.95 moles of calcium. And there's your answer for that. Number 10. How many moles are in 5.18 grams of copper 2 oxide? Well, find the molar mass of copper 2 oxide. This is going to be copper plus oxygen. And this is 63.55 plus 16. So this is equal to 79.55 grams per mole. Draw your dimensional analysis line. Write down what you're given first. 5.18 grams of CuO. And on the bottom here, we denote the unit, grams of CuO, moles of CuO. And we have 79.55 grams is equal to 1 mole. Cross out the units that are at the top and at the bottom, and we're going to multiply across the top. 5.18 times 1 divided by 79.55. In your calculator, you would type in 5.18 divided by 79.55, and your answer here is going to be a small number, 0.19 moles of CuO, of copper 2 oxide. All right, our next problem, how many moles are in 2.35 grams of lead nitrate? Find the molar mass of lead nitrate first. So PbNO3(2) is equal to lead plus 2 nitrogen plus 6 oxygen. And when we add this up, we get 207.19 plus 2 times 14.01 plus 6 times 16. And when you plug that into your calculator, you get a molar mass of 331.21 grams per mole. So we have only 0.235 grams of lead nitrate and we demote the units, so we have grams of lead nitrate at the bottom, and that's equal to moles at the top. We have 331.21 grams is equal to 1 mole of this compound, and we need to multiply 2.35 times 1 divided by 331.21. In your calculator, you would punch in 2.35 divided by 331.21, and your answer here, it's a small number, it's going to be 0.007 moles of lead nitrate. Okay, last one. How many moles are in 15.3 grams of ammonia? Ammonia is NH3, and that's going to be equal to N plus 3 H's, which is equal to 14.01 plus 3 times 1.01, which is equal to 17.04 grams per mole. Write down what you're given, 15.3 grams of NH3. Draw your lines, demote your unit, write what you're looking for at the top, moles. We know that the number next to grams here is 17.04, so we're just matching. 17.04 grams goes at the bottom, that's equal to 1 mole. And you have to multiply across the top, so we have 15.3 times 1 divided by 17.04. So in your calculator, you need to type in 15.3 divided by 17.04, and when you divide that out, you get 0.90 moles of NH3. All right, there we go, chemistry students. I hope that this was helpful. I'll see you in class. Bye-bye.